Hey, now let's graph these bad boys and look at how these polynomials work. And there's really some kind of cool things that make these polynomials up.
Absolutely. And so if we've graphed each of these for you so you can see them as we talk about them.
Put it on your calculator, do it at home.
Yeah, so what's neat is that, if we just have a cubic function, we all know what like y equals x cubed looks like, especially since we just did it in the last problem. We all know what x looks like, y equals x, that's a line.
Straight line.
And so, but what's neat is if you think about x cubed plus x, and if you realize what's going on there, look over here at this graph. We have a cubic function, but here in the middle, where it's really close to 0, this cubic function looks like the line y equals x.
I think I would agree with that.
Which has to do with these being the two monomials that our function is built from. And if it's not obvious on that one, check out the next one. To me, this is where it really brings it home, and it's like, oh, hey, that's actually really neat. X cubed minus x, well, the line y equals negative x is going the other direction.
Because of the negative slope.
Because of the negative slope. And check it out. Right here, we have a negative slope right there. And so, yeah, really close to 0, this looks like the line y equals negative x, which was this part of this binomial.
So they are completely mashed together, but each part of the monomial takes on specific aspects in the graph. It's really cool.
Yeah, it is really cool. So when you're doing this at home or on your homework, like that's what we're looking for whenever it says how it's related to the monomials from which it is built. Well, we want you to notice that, hey, here in these two cases, here in the middle, you can see the x or the negative x part of it, and then out towards as you go out, that's where the cubic function really takes over.
Right. Some things that we can get from this, though, are what are called local extrema, and there's some debate on exactly 100% what local extrema is, but in this case, it's really evident.
Yes.
Local extrema is going to be a maximum y value or a minimum y value, or like a peak and a valley. Right. Is what you're looking for.
We're looking where the graph switches between increasing and decreasing, or vice versa. So on this first graph, that doesn't happen. This function is increasing the entire time.
The whole time.
And so this would not have any local extrema. So if it tells you to locate it and there aren't any, you need to say, hey, there's no local extrema. And in precalculus, we only care about the local ones, and so if you don't say local, that's fine. A global max or min is a little bit different, and you'll talk about that in calculus. The zeros on this graph, well, we could calculate it with our calculator, but this one's really easy to see.
It goes through the zero.
Origin.
The
zero,
origin.
Zero.
One thing, too, with the zero is you could actually see that used several different ways. This particular question asks for a 0. You could also be asked to find a root. You could also be asked to find an x-intercept.
A solution,
you could be asked to find a solution. All of these are the exact same thing. Root, 0, solution, x-intercept, all represent the exact same process.
Is this how we want them to write it? 0 at x equals 0?
That sounds perfect.
That sounds great. So if the 0, if it had intersected somewhere else, you'd just say a 0 at blah, blah, blah.
And when you're using your calculator and you want to find where a graph crosses the x-axis?
You go to second trace.
Second trace, and guess what?
It's an option.
0.
Yeah.
0 is the option.
You find the zeros. And it does kind of like maxes and mins. It asks you for something below. Like it asks you to start over here, then pick a point over here, and then it asks you to guess, and then it guesses in between.
Right.
So the next one we want to look at for the extrema. So we've got an extrema right there, a maximum. I wonder what that maximum is. Oh,
get purple, yeah, purple.
Yeah, purple.
There you go.
Right here, this is a maximum because this is where the graph switches from increasing to decreasing. We don't have a calculator.
I got a calculator right here. Hold on one second.
And then we also have a minimum over here. We're going to find those two things using our calculator. So you do second trace.
Okay, first,
max.
yeah, so I'm going to go for second trace for x cubed minus x. Oh, x cubed minus x. So there it is right there. There's our graph. And on the Inspire, you actually hit the menu Analyze button, and one of the things that you can pick is min or max.
Yep.
And So which one are we on, max?
Whichever.
So the maximum is going to be, occurs at, there we go, okay. Negative, it's all suspenseful, it's all very suspenseful. 0.577 is your x coordinate.
You said negative, right?
Negative 0.577.
Okay.
And the y coordinate is 0.38. And on these kinds of questions, because it builds to AP, the AP coursework, we round at 3 decimal places, and we would actually encourage you to not round to just truncated 3 decimal places so that you don't make a rounding error.
So if I truncate this, that means cut off at 3 decimal places, so that'd actually be 0.384.
0.384.
Okay, so now find the minimum.
So the minimum then is,
Also, I like having the whole point whenever you tell me a max and a min. Don't you like that?
whole points
Whole
are
point.
fabulous. There's no confusion.
Yeah.
So we don't want you to be confused. Hey, guess what?
What?
I think it's going to be very similar.
Oh, it's probably going to be positive 0.577 and negative 0.384. Is that right?
That is 100% correct.
You know how I knew that?
How did you know that?
Because this is an odd function.
Son of a shut the front door.
That didn't even make any sense that you just said that.
That's
How did
crazy.
those things go together?
Well, they just come out.
This is an odd function. Actually, the first one was as well. Because for one thing, both of our exponents here are odd. That's one way you can tell. And the other is we've got some symmetry about the origin. You can take what's in the first quadrant, rotate it around, it's in the third quadrant.
One way you could do that is if you take your graph of your calculator and it's got this guy, and if you spin it upside down and it's the exact same graph, that's another way you can tell.
Yeah. Just turn everything upside down.
Turn everything upside down and it should be the exact same.
We actually have 3 zeros here.
Oh boy, 3 zeros. I know what one of them is.
I think I know what all 3 of them are.
I know one of them is when x equals 0.
Just like last time.
Yes.
I would say the other 2 are at negative 1 and positive 1.
I could not argue with that at all.
And, it's pretty easy for us to look at this and, it's pretty clear. And also it'd be really easy for us to plug back in and check. But, on your calculator, it's usually not good enough to just guess.
No, don't guess. And don't ever just use trace either on your calculator. Actually use the 0 feature on your calculator.
Yep, second trace.
Second trace on the 84s and menu analyze on the inspires.
Yep.
Okay.